Rewrite the following words as they would look if you held this word up to a mirror. So with your mirrors, you should be able to look at those words. And what I want you to make sure you do is draw your line of symmetry where those words would end up. Are there any questions on how to check in your writing if they match? Remember, the line of symmetry is where the reflection is happening. So you put your mirror right there. First, on the test, you have to make sure you look and see how the words are going to look on the other side. And after you write them, use the mirror and then check. Do those words match the way they're written on this side? And that's where you got to look at the English here. Okay? All right. Okay, everybody okay with that problem right there? That one's pretty easy. Okay. If I'm going too fast, it's very important that you are paying attention and you're making sure. Hold on, I have a question. Okay? All right. If not, I'm going to assume and I'm just going to move on. Okay? This one was a multiple choice question. That one pretty simple. You don't have really any work to show me. All you got to do is tell me which ones. It says circle the shapes that are a reflection. That doesn't mean there's only one possible answer. Okay, it could be two, could be three, or it could be all of them are a reflection. Okay? The ones that are a reflection, B is a reflection. Right there. And that's it, just B. This one is not a reflection. This one is a translation. Yeah. This one over here, translation, and then reflection. Notice how C, when you translate it, then they flipped it. That's a blind reflection. What about C? What would C be, you think? Looks like it's maybe a rotation, maybe? Yeah. You have to figure out where would be the point of rotation. Remember how you put your pencils on your pad paper to rotate it? C looks like it's possibly a rotation. And it could be rotated like this. Somewhere the center should be somewhere over here. Okay. As a point of rotation. Right, so everybody okay with that one? There could have been two reflections. Okay, in this case, there was only one. All right, you have to make sure you look at all of the possible choices. Maybe the question on the test is not going to say which ones are reflections. It might say which ones are translations. Yeah? Okay. Or maybe it'd say which ones have a glide and a reflection. Yeah? Okay. All right, everybody go to this problem. You're taking as many notes as you can. Okay. All right, on this problem right here, very carefully it says, how can you tell if a motion is a reflection? That's one question that you have to answer as a sentence. Not one word, not two words. It has to be a sentence format as how you're explaining things, okay? And then it says, study each picture below and explain why or why not the image is a reflection. So first, you gotta make the answer. How can you tell if a motion is a reflection? So when you look at something in the mirror, what is it that's always happening? Reverse? Okay. Give me another word that we can use for reverse. Opposite or flipping? Yeah. In reflections, the image should face the opposite of the original. Now, is that the only way you can explain a reflection? No. Does anybody have another way you could explain it? That's a good answer. How else can you explain a reflection? Remember the activity that we did where I made you guys fold the paper? Remember when you folded the paper, you creased it, right? And you made a line of symmetry? If it was a reflection, the folding is where the mirror would be. The line of symmetry is that same folding line. If you do a reflection, it should map on top of itself when you fold it like a piece of paper. That's another explanation you could state, okay? Now we're going to answer the next question. It says, is the picture below a reflection? And why not? So yes or no is an answer, but you got to explain why is it yes or why is it no. So is that a reflection, everybody? No. You could just say not a reflection. I would state the image above is not a reflection, but it's asking you, explain why. If you put that, that doesn't mean you got the full answer. You didn't answer the question completely. That's not enough. Why can I say it's not a reflection? Well, let's finish it. Let's explain it. Why is this image not a reflection? What's wrong? Okay, Michael? Okay, they're not opposite. What is it that you guys are focusing on that's making you think that? Right? They're both facing what part of the object is it that you're referring to? The eyes. So you would state that. The eyes are both facing the same direction. The image above is not a reflection because the eyes shouldn't they be facing each other to be a reflection? Yeah. So you would just state that it's not a reflection because the eyes should be facing each other, not going the same direction. Okay? And why are you saying facing each other? It's because they're doing the opposite to each other. Yeah. Okay. Does that explanation make sense? Yeah. Okay. So from there, read the directions. What are we supposed to do? Graph it. It's already done. What else? Reflect it on what? X-axis. Which one's that one? The one that goes horizontal or vertical? Horizontal. So do me a favor. Draw this orientation. It says you're going to reflect it from this side over here. Yeah? All right. Now, does everybody know that this point has a name for it? Does anybody remember the name of that point? Somebody say it. Vertex. Put that in your notes. That is called the vertex. Yeah? That's where the parabola is either going up or down. If it's a vertex and the parabola is going down, that's a maximum. So imagine somebody throwing a ball. It reaches the vertex and then it starts to go down, right? If the parabola is like this, that vertex is a maximum because you threw the ball up in the air and it reached a maximum height. Now it's going to come down. Okay? If it's going the other way, where it's going down, 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 and then it rebounds and now it starts to go up, that vertex then would be a minimum because it went this way, kind of like a U. Okay? All right, so do you notice How far is the vertex from the line of symmetry that we're supposed to reflect it on? 2 units. So that means it should be 2 units up, to the left, or to the right? Just up, because you're reflecting it like a mirror, right? So go ahead and draw a dot right there. And which direction should the graph be drawn? Doesn't have to be perfect, just try to match it as best as you can. Notice I stayed somewhere between these lines, so I just try to stay again. Like that. Everybody okay right there? Yeah. It says reflected across the x-axis. We've done that. Justify why you know your answer is a reflection. So, with your mirror, the reason why you can justify why your answer is correct is because the original graph is going down with a y-intercept at y equals -2. The reflection on the x-axis should be vertical. The reflection on the x-axis should be vertical, so the vertex is now on y equals +2, going up. And all you're stating is this point, because it's reflected on this axis, it's going to be a vertical reflection. That point, which is 2 units away, is now over here 2 units away at +2. And now the parabola, instead of it going up, instead of it going down, it's going up, which indicates a reflection of that image. So you're just pretty much stating how you figured it out. Okay? All right, so take a look at your answer is a drawing. That's all it is. Okay? All right. Reflections, you guys understand how to use these little mirrors to help you check them? Yeah? All right, now take a look at this one. It says draw a sequence of reflections over non-parallel lines. Here's now if you already did your drawings, that's fine. Technically, they wanted you to do this reflection over here first. And that would cause you to make the drawing look somewhat like this. Then you were supposed to reflect that image on this line over here. So no matter what, if you reflected it over here first, that's okay. Then you still had to reflect it on this line. Either way, everybody should have ended up in here no matter what. Yeah. I'm off a little bit right there. Okay. You notice my size is a little bit, it seems a little bit more bulkier. Just try to keep it as best as we can to the original. And I know it's not going to be perfect, but just try to match, make the sizes, try to keep them the same. Don't draw the arrow so big that now you actually transform it to be a huge thing. Okay? Try to keep the size and the shape the same. As best as you guys can, okay? All right. Everybody okay with that one, I think? Yep. Okay. Over here, it says, name the sequence of transformations that will move from figure A to A prime. So let everybody take a look where A is. And everybody see where A prime is. What is the transformation that will allow us, now you got to keep under consideration, This whole figure has to map right here though, okay? What type of, is it more than one transformation you think? Yeah, I think so. Now, it's possible there could be different combinations that you could do this, okay? If we were to rotate this figure about the point E, this would be 90, this would be 180 degrees. Would the letters match? A would be there. B should be right here. Or I'm sorry, no, you're right. B should be right here. C would be there. B. A rotation would match it, wouldn't it? 180 degrees. Okay. That's one type of transformation, isn't it? Is there a different way we could have made it go from here to here? Glide? Not a glide. If you do a reflection on this side, or you could do it here, this way, and then do another reflection on it, you can map it. So if you flip it here, and then flip it there, twice. Does that make sense? Would it match? If I flip it here, A stays there, B would be over here, C, D, and E, right? And then I flip it again on the x-axis, D's and E's are going to match. C, C's and E. So you could either have two reflections, one on the x-axis or the y-axis first, and then one more reflection. Or you could just do a rotation. Two different ways you could have done this, okay? Either answer would have been correct, okay? All right. Yes is correct. Now give me an example of a transformation. Is there only one type of transformation you could have done? Whatever you can think of would be correct. If you say move it to the right 3, up 1, and then reflect it, that's a transformation. Yes? If you stay rotated 90 degrees and then translate it, that's a transformation. So every one of you in here could have a totally different explanation of do this and then this. Yeah? But you got to give me an example, so I'm going to go ahead and put one. Yes. Move up 3 and down 1 and reflect on y equals 2. That's just an example. Okay? That is not the only example you could have used, okay? I'm just throwing one out. Okay? Did I finish answering the question? No, there was another part. Are there always multiple ways to describe any transformation? Technically, you could transform anything anyway, couldn't you? Now, unless there's a restriction, then you would say, well, depending on the picture, yeah? So, depending on the picture, there are many ways. And there's many ways, because it all depends on how the picture was given to us, yeah? Oops, and I forgot. Right here, I should have put depending on the picture. I thought that, but I didn't write it. Okay, that's supposed to go right here. Depending on the picture, there are many ways. Does that make sense? The way I wrote it, depending there are many ways, doesn't make sense, does it? My English grammar is very odd. So can you guys put something in there that says, depending on the picture, you don't have to erase anything, just you know how to put that little arrow says that that's supposed to go in there. Yeah. Okay. All right. So do you guys see how you can answer that a couple different ways? Yeah. All right. Graphing that's got to be super easy. Yes. What's the y-intercept on this graph right here? So go to the y-axis at +1. And what's the slope? Up 1. To the right 4. Put a dot there. You can go down 1 and to the left 4 so you can connect all your points. Yep. So the graphing of those equations, everybody feel confident on those? You can do those super easy? Yep. All right. Now we look at the directions. It says graph that equation. We've done that, okay? But using tracing paper to translate the graph up, that would be the patty paper, but you really don't need the patty paper for this one. Just translate the graph, what? Down 3 units. So that means here, this dot, move it down 3. So then the y-intercept is really now at -2. The slope did not change. So go up 1 to the right, 4, go down 1 to the left, 4. Or you could just move this dot, 1, 2, 3, down. And this dot over here, 1, 2, 3, down. And just connect your new points now. Can you label in your drawing this is the original? And this is your new image? Just so I know that you know that. Okay. This was just a translation. It just went down, right? Okay. Any questions with that one? All right. Go ahead and plot those points. -6, -3. Label it the letter M. And -3, 1. Label that the letter P. Everybody okay with the points? Plotting them, where are they in the right direction? Yes? Okay. The only thing left is you got to reflect those points on the line y = 2. I already showed you how the graphs of y equals are always going to be vertical or horizontal. Vertical will always be x equals. Horizontals will always be y equals. Yeah? So go to the y-axis at what number? 2. Y-axis at 2, and the line is horizontal through that point. You are going to reflect those dots over here. And it's going to ask you, what are the coordinates of M prime and P prime? So what should be the coordinates of P prime now? -3, 3. Go ahead and plot that point and label that your P prime. Everybody see it's just 1 unit away from the line of symmetry? Just on the opposite direction of the line of symmetry. What would be the coordinates for M prime? 6, comma. What was the other number? 7. So this is 3, or this is 1, 2, 3, 4, 5 units away from the line of symmetry. So I got to go up 5 from here. 1, 2, 3, 4, 5, and that's 6, comma 7, which is 4. Remember, the distances need to match opposites. Any questions with that one right there? No? Easy. All right, this one, translate that figure which way? to the left 5 and up 4. Every dot, just go to the left 5, up 4. Okay? So 1, 2, 3, 4, 5, up 1, 2, 3, 4. That's this point. 1, 2, 3, 4, 5 to the left, up 1, 2, 3, 4. That's that point. And then this point is just 2 units away, so it should be right there. Do you notice this part right here is somewhere between about 1.5 units away from this point right here? So you're just kind of roughing that out. And then connect your points and draw your arrow or your vector saying that's the way it went. That make sense? Yeah? Right? Any questions on that one right there? No? Okay. All right. Almost done. All right, reflect the line segment AB across line C. So when you reflect it, you would put your mirror right here where the line of symmetry would be. Look at what the line's supposed to look like, and if you notice, the distance from here to here should be exactly the same on the other side, shouldn't it? So just keep in mind that that distance should put B prime somewhere over here. And the length of this segment, AB, is not changed. Does everybody understand that? AB has not changed. It's just being flipped on the other side. So that means B prime to A, B prime to A should make a triangle. You guys see the triangle now? Yeah? Very important. This segment, however long it is, and this segment, what do you know about these two sides? They're both equal. So in geometry, you would say this segment and this segment are congruent with these little tick marks like that. Okay? These two sides are congruent. I don't know how much this side measures. I don't know if it measures the same as these two. The only thing I know for sure is that this one and this one are the same. Yes? Okay. So now it says, connect B to B prime. We already did that. We created the triangle. Yes? What type of triangle do you have? We have a triangle with two sides that are congruent. Does anybody remember what a triangle with two sides that are congruent is called? Starts with an I. Isosceles. What if three sides are congruent? Equilateral. If none of the sides are congruent, then that's called scalene. Yeah? So you could also state, since it has two sides that are congruent, that's also referred to as an isosceles triangle. What do you know about the sides of the triangle? Well, only two sides are congruent. Okay. What do you know about the angles of the triangle? Oh, this is a good one. If only two sides of the triangle are congruent, how many angles are there in a triangle? Three angles, always, yeah? If there's two sides that are congruent, the angles opposite them have to be congruent. We don't know what they measure, but they have to be congruent. So what do I know about the angles of the triangle? Two of the angles are congruent. don't know how much they measure. What if 3 of the sides were congruent? It's equilateral, right? If 3 sides would be congruent, that means 3 angles have to be congruent. Okay? If none of the sides are congruent, none of the angles are congruent. Does that make sense? Okay. That's what we're going to get to in the next unit. Unit 2, we're going to talk about triangles. Okay? So right now you're just kind of being introduced to some of the basic things about triangles. Okay? All right, everybody okay with that one right there? Yep. All right, draw all possible lines of symmetry. If you only draw that line, that would be wrong. There's another one in the middle going horizontally. Would that be it? Yeah. Now, do you know how to check to make sure your lines of symmetry are correct? The little mirror. With the little mirror, you should be able to put your mirror on those lines that you just drew, and that diamond looks the same on that reflection. Yes? Yeah? Okay. Are we missing any other lines? Because if we are, then our answer is wrong, okay? So you got to check with your mirrors. Move it around, okay? All right, how about okay, now notice number 1 said only line of symmetry. It didn't say angle of rotation or rotational symmetry. Remember that rotational symmetry, the figure, if it goes all the way 360 till it matches, does that have rotational symmetry? No. If you have to move the figure 360 degrees and then it matches itself all over again, that does not have rotational symmetry. It has to match somewhere before you get to the 360 degree rotation, okay? Whether it's 10 degrees, 180 degrees, or whatever, okay? Does the second problem, the first image, does that have a line of symmetry? Yeah. In that line of symmetry, is it vertical or horizontal? Both. One going here. Check it. Check your mirrors. Does that match it? And then the other one is this one, isn't it? Those are the lines of symmetry. Now, if this is the center of rotation right here at where those 2 lines intersect, if I rotate this figure just 90 degrees, it's going to be tilted sideways, right? Did it match itself with 90 degree rotation? No. Okay, rotate it 90 more. Does it match it then? Yeah. So it's not until 90, or not 90, 180 degrees that it'll match. It says identify the rotational symmetry in degrees. So the angle of rotation is 180 degrees. Now, do you see how to use your patty paper to figure this out? You would copy the image, put your pencil where the point of rotation is, and rotate it until it matches. If you have to rotate it all the way around, it does not have rotational symmetry. It has to be less than the 360 degree rotation, okay? All right. On the next image, does it have rotational symmetry? There's one problem I didn't catch it. Did anybody notice something in this picture? There is no line of symmetry, and there's one problem, and that's one little thing that's messing the whole thing up. You see it, Derek? The arrow in the corner of this one? Yeah, this one, something's wrong with this arrow. You see what's wrong with it? You see these arrows right here? And that's just the typo. It should have been like that. Okay, so just, can you fix that real quick? Can you fix that on there? Now, does it have rotational symmetry? No? If you were to rotate it from here, so I rotate this. This one would match there. This one, oh, there's another problem right here. It's not good. That was a typo. When you're putting all the images on, let's see. Can you fix that part right there? Because that messes up the whole rotation. Because that it doesn't have rotational symmetry. With those two changes, though, the images would have 1, 2, 3 different spots where it would rotate. How do you find that angle? Divide 360 divided by 3, because it has 3 different lines of symmetry. 360 divided by 3. This is how that division looks like by 1. 3 goes into 3 once, remainder of 0, bring down to 6, right? 3 goes into 6, not 3 times, 2, with a remainder of 0, bring down to 0. So what would be the angle of rotation then? 120 degrees. Remember, it's asking us for that angle, okay? All right, identify the rotational symmetry in degrees. Is that last figure, does it have line symmetry that could be used for rotational symmetry? Yeah? How many do you see? 5? Okay. Where does each one start at? In the middle. Now these points are called vertices. Okay, the vertex of the star, right? So if you start one line of symmetry right down the middle, right there, would that fold on top of itself? Yeah. You can check with the mirror, right? You see that it does fold, right? So do you see all the other ones? There's 1. There's 2. There's 3. There's 4. And there's 5. And technically all of them are meeting at this point here in the center, right? Okay. So here's my point of rotation then. How do I figure out these angle rotations then? Divide 360 divided by 5. That's 360 divided by 5. 5 goes into 36, 7. With the remainder of 1. And then 0. 5 goes into 10, 2. So the angle of rotation is 72 degrees. Okay, you guys getting the hang of that? Yeah. Last one. It says it's a regular hexagon. Now, regular means all the sides are the same or congruent, equal. All the sides are equal. The picture might be off a little bit on your paper. I tried to fix that, but it's this top at the bottom side that might be off a little bit. So when you use your mirrors, that's why it's not going to match completely all the time. So there's another typo right there that the drawing is off a little bit. I know, I'm sorry. How many lines of symmetry do you see? 5? 6. Okay. Is this one of them? Yeah. Is that one of them? No. Okay, that's 3 of them, right? Okay. Are those the only ones?
The center.
Okay, the center, so from the vertices, yeah? So we've counted 1, 2, 3. Let's just keep track of them, yeah? Is that right? Oh, okay, this one right here? That one right there too? I just drew this one. Just drew this one. That's fine. Is there any others that are missing? Yeah, just adding on this one right here. So that gives us 6 total. Yes? How do I find the angle of rotation again? Divide. What do I put on the top? 360 divided by 6. So the division just looks like this. Yeah? 6 goes into 36. 6 times with the remainder of 0, bring down the other 0, and the angle of rotation is 60 degrees. Yes? Did we finish all of the problems? Oh, there's one on the test. Oh, okay. Describe how you would determine if a shape has rotational and reflection that carry an image back onto itself in terms of symmetry. So I would go back to some of these examples that we wrote up. And we actually explained, I think, over here. Reflection. In reflection, the image should face the opposite of the original. You understand? You can use that as part of the answer for reflection. Okay? For rotation, the figure has to rotate about a point of rotation, and it has to match on top of itself less than 360 degrees, because if it takes it 360 degrees till it matches it, no, it does not have rotational symmetry. Okay? So you see how you would write that as a sentence in that very last question? Yeah. And you could use this as part of the answer. The other part would be the rotation, rotational symmetry. The figure has to rotate and map onto itself less than 360 degrees to have rotational symmetry. Okay? All right. So I'm going to leave you guys to answer that last one on your own, okay? All right. Are there any last minute questions then? No? Okay.